Hello, my dear students. Welcome back to our channel motivus. This is the fourth lecture series of some basic concept of chemistry. So we have finished three lectures, and today we have discussed about how to find out the number of moles. So we are into the mole concept detailing. Before moving to that, we should recollect what all the things what we have studied. So we have discussed about the atomic mass and we have discussed about the molecular mass. What is gram atomic mass? It is a mass of 1 gram atom. That means its numerical value of atomic mass of an element is expressed in gram, then the value become gram atomic mass. It's similar as that, as we said 1 U is equal to 1 gram per mole. So this is what you should remember all the time. Numerically, the mass of one atom will be equal to the mass of 1 gram mole of atom, right? So let's talk about that. When numerical value of atomic mass of an element is expressed in gram, then the value become gram atomic mass. Let's say if I write like this is 16U, mass of one oxygen atom. That is the numerical value of atomic mass of an element. If I express that in gram, this value become gram atomic mass. So gram atomic mass is mass of 1 gram atom. Just remember 1 gram atom. If somebody is telling you it has 1 gram atom, make sure that it is 1 mole atom. You understood it like 1 mole atom. 1 gram atom, 1 mole atom. 1 gram molecule, 1 mole molecule. 1 gram ion, 1 mole ions. That is how you have to consider. So gram atomic mass is the mass of 1 gram atom, and that is nothing but the mass of 1 mole atom. Mass of 1 mole atom means mass of Avogadro number of atom. Mass of 6.022 into 10 power 23 atom. Similar way we can go with the gram molecular mass. When the numerical value of molecular mass of the substance is expressed in grams, then the value become gram molecular mass. Let's say again, if you talk about the oxygen molecule, what is the mass of oxygen molecule? You can write as a 32U. This is molecular mass of a oxygen molecule. Now if I write it like this one, this is going to be mass of 1 gram molecule of oxygen. That is molecular mass expressed in gram. Mass of 1 gram molecule of oxygen means mass of 1 mole molecule of oxygen. That is nothing but mass of Avogadro number of molecules of oxygen. Obviously mass of Avogadro number of molecule of oxygen. So make sure that you are getting the idea correctly. If they are talking about 1 gram molecule, that is 1 mole molecule. If they are talking about 1 gram atom, it is 1 mole of atoms. If they talk about 1 gram ion, it is 1 mole of ions. Okay, now we'll be talking about the average atomic mass. You know, the atomic mass is represented in the periodic table is not actually the real mass. It is the average of the different isotopes of that particular element. So how we are going to find out the average atomic mass? To find out the average atomic mass, you can have the equation xi into mi by xi. What is this one? Xi is nothing but the percentage abundance. Okay, we can write as this is percentage abundance, and mi is the mass of the element. Mass of the element. Let's say we got two isotopes. We got two isotopes for a particular element x and y, and x is having a mass 200 and y is having a mass 195, and x is having the abundance 80% in the atmosphere, y is only abundant at 20% of the atmosphere. Then if you wanted to find out the average atomic mass, so mass of x into abundance of x plus mass of y into abundance of y, then percentage abundance of x plus x of y. So that is, I can write as mass of x, it is 200 into abundance of x 80 plus mass of y is 195 into percentage abundance 20 and the summation of the abundance, that is 100. So this is how you can solve the average atomic mass related question, right? We'll go with the one question. It's 1990 question. Boron has two stable isotopes B10 and B11. calculate the average atomic weight of boron in the periodic table. We have to find out the average atomic weight of boron in the periodic table. Let's find out that what will be the equation. As we have seen, average atomic mass is equal to summation of xi into mi by xi. So what you are gonna get? First one, boron. What is the mass? B10. 10. What is the abundance? 19. Plus the second isotope, mass is 11 and its percentage abundance is 81. Divided by total abundance, 81 plus 19. That's gonna be 100, right? So what is gonna be the value? Average mass is going to be 10 into 19, 190 plus 11 into 81. What will be 11 into 81? Is 111818. So 19891 it seems. Okay, 891 by 100. So what you are going to get? 1 8 1081 by 100. So average atomic mass is going to be 10.81. You got the option right here. First option, 10.8. This is how you have to find out the average atomic mass. Now let's talk about the moles. How you are going to find out the moles? If you wanted to find out the moles and they have given you the mass in gram and also they have given you the number of molecules, you can go in two different ways. If they have given you the mass in grams, then we can say that number of moles is equal to mass in gram by molecular mass. N is equal to W by molecular mass. If they have given the number of molecules and we wanted to find out the number of moles, the equation is N is equal to N by Na. N is number of molecules and Na is Avogadro number of molecules. If we wanted to relate this one, obviously we can relate that N is equal to W by molecular mass into Na. How this relationship came? Look at that. What is N? N is equal to given mass by molecular mass, right? So instead of this, I can write as N is equal to N into Na. From where I got this equation, that is here N is equal to N into Na. So you can relate both these. And from here you got a lot of equation, a couple of equation to find out the number of moles. Let's recollect all the equation. Number of moles is equal to given mass by molecular mass or given mass by atomic mass. That depends with respect to what they have given. Okay, and molecular mass, this is if they have given weight in grams. In the question they have given the weight in grams, then you can use number of moles is equal to mass given mass by molecular mass. If they have given you the number of particle, N is the number of particle, it can be molecule or anything, number of particles they have given. If they have given the number of particle, N is equal to N by Na, as we have seen here, right? N is equal to N by Na, number of molecule is N. So you got N by Na. And you can have one more equation, N is equal to V by 22.4. N is equal to V by 22.4. This cannot be applicable on all cases. This is applicable only at NTP condition. Usually for solving the problems we are considering NTP is equal to STP, even though there's a little difference between 1 bar and 1 ATM. You know that 1 bar is equal to 0.987 ATM, but that difference is negligible as you see. So at NTP or STP, if they ask you the question, N is equal to V by 22.4. You know what is 22.4? What is 22.4? Is the volume occupied by 1 mole of a gas, occupied by 1 mole of a gas at STP. Okay, STP, actually NTP, right? STP, if it comes to STP, you know, it should be 22.7, but for the numerical purpose, we are still keeping it as 22.4. So number of moles is equal to V by 22.4 at NTP or STP. So these are the three equations that you should remember to find the number of moles. Okay, if you got the number of moles, how will be finding out the number of molecules or number of atoms? That is another equation, right? So if you wanted to find out the number of atoms, first we will be writing the equation for number of molecules, as we have seen here. Number of molecules is equal to N into Na. We can write number of molecules, that I will write here, number of molecules is equal to N into Na. Na is Avogadro number. What is N? N is number of moles that we can find out from here. W by molecular mass. Fine. If you wanted to find out the number of atoms, if you find out the number of atoms, we have to use the equation N into Na into atomicity. We have seen this equation. What we meant with this atomicity. Atomicity is nothing but the number of atoms in a molecule, right? Number of atoms in a molecule. We have seen in the last lecture what is atomicity, right? H2, you got two hydrogen atoms, so number of atoms in a molecule is going to be 2, so the atomicity is 2. So these are the three, not only the three plus 2 5 equations. These are very important equation. Number of moles can be found out by given mass by molecular mass. Number of moles can be found out by N by Na, and number of moles can be found out by V by 22.4 only at STP or NTP. And if you wanted to find out the number of molecule, you use the equation N into Na. If you wanted to find out the number of atoms, you use the equation N into atomicity. Now we'll solve these questions. We'll solve few questions, so you'll be getting more and more clarity regarding this one. Find out the number of moles in 11.2 liters of oxygen at STP. Look at that. They are asking the number of moles. Fine, we have to find out the number of moles when at STP. What they have given volume in liters. They have given volume in liters, 11.2 liters. Volume in liters they have given. They are asking us to find out the number of moles, and they are telling that it is at STP. So number of moles is equal to V by 22.4. V is 11.2 and divided by 22.4. This is nothing but 1 by 2. So you will be getting 0.5 moles. So this is what the number of moles in 11.2 liters of oxygen at STP. You got clarity, right? Yes, 0.5 moles. Now, if you wanted to find out the volume and moles in 56 gram of nitrogen at STP, you wanted to find out the moles as well as the volume this time, and they have given 56 gram. They have given the weight in grams. So if they have given you the weight, how you will be finding out the number of moles? Is number of moles is equal to given mass by molecular mass. So find it is 56 gram of nitrogen. What is the mass of nitrogen in 2? That is mass of nitrogen is 32 grams. So we've got 32. Oh, sorry, it's not 32, it's 28. Man, yes, it's 28. Okay, it's all the time oxygen is coming to the mind. Yeah, of course, oxygen is needed for our survival, right? Yeah, 56 by 28. 56 by 28. So you got the 2 moles. What is the 2 mole? 2 moles of nitrogen gas is there with us at STP. Then what will be the volume? At STP, we have to find out the volume. The equation at STP related to volume is V by 22.4. So V is equal to N into 22.4 liters. What is N? N is 2 moles. So 2 into 22.4 liters is what we are calling as 44.8 liters. You got the point? Yes, this is how you have to solve. Now look at that next question. What they have given? They have given again 1.12 liters of ozone at STP. What we have to find out? We have to find out the moles and mass this time. Initially they have given more mass. We found out moles and volume. Now they have given you the volume. We have to find out the moles and mass. You can do this, right? Yes, they have given the volume. They have mentioned it is at STP. So V by 22.4 liters cool. So V is equal to N. Sorry, we wanted to find out N, right? N is equal to V is 1.12 liters by 22.4 liters. So we can write as it 11.2 by 22.4 into 10 power minus 1, right? So this is 1 by 2. 1 by 2 into 10 power minus 1. So the answer is going to be 1 by 2 is 0.5. So 0.05 will be the answer for the number of moles. Then we have to find out the mass. Again, we have to substitute number of moles is equal to given mass by molecular mass. That implies mass is equal to N into molecular mass. N is 0.05, that I can write as 5 into 10 power minus 2 into molecular mass of ozone. Ozone, what is the mass of ozone? Mass of ozone is 48, right? How you got it as 48? Oxygen is 16, 3 oxygens are there, it's 48. So 48 into 5, you got the answer is 48 into 5, 240. So 240 into 10 power minus 2, the answer is going to be 2.4 moles. Sorry, what 2.4 grams. 2.4 grams. So we found out the weight, we found out the mass, that is nothing but the weight, 2.4 gram. We found out the moles, that is 0.05 moles. Right, this is how you have to find out the answer for this number of moles of questions. We'll go with this questions as well. Now we have to calculate the number of atoms, not the number of moles, but we have to find out the number of atoms. Okay, let's take a look. Number of atoms in 1600 gram of oxygen. Number of atom, what is the equation? We have studied already, right? Number of atoms is equal to n into Na into atomicity, right? N into Na into atomicity. What is n? Given mass, they have given the mass, given mass by atomic mass, so you can go with 1600 by atomic mass of oxygen, 16 into Na. Atomicity, this is single oxygen, so it's 1. What you are gonna get? You are gonna get number of atoms are 100 Na. You got that? You got the number of atoms as 100 Na. That is how you have to find out the number of atoms. Let's go with the second question. 2.3 kilogram of sodium. Again, number of atom equation. Number of atoms are finding out by n into Na into atomicity. Find n into Na into atomicity. So n you have to find out. They have given the weight, but as I told you, weight in gram by gram molecular mass. This is what the equation to find out the number of moles. This is weight in kg. So 2.3 kg can be converted into 2300 grams. So we'll get the equation 2300 by atomic mass of sodium is 23 into Na. Again atomicity is 1. So it's gonna be again 100 Na. The same you have to go with the 32 kilogram of sulfur. 32 kilogram of sulfur now is just 32,000, right? 32,000 by mass is again 32 into Na into 1, because only one sulfur is there. Again what you are gonna get? You are gonna get 1000 Na. Am I doing it right? Right, 32 kilogram, yes, 32,000 gram. Fine, you got the answer. Now look at that. With this, we'll wind up. Okay. So calculate the number of atoms in each of the following samples. They have given 3 different samples, and you should be very careful. After doing this, you will get the idea how to find out the number of atoms. Right? Look at that. 52 moles of helium. So for the 52 moles of helium, how we are going to find out? Number of atoms. We know that is given mass by atomic mass. Number of atoms equation நம்ம எழுதிடலாம். N into Na into atomicity. We are writing N into Na into atomicity. Now n already they have given, we don't have to find out the n. So 52 into Na, and helium is just one helium, so 52 Na is going to be the number of atoms for the first option. That's fine. So second option, 52 U of helium. 52 U, this is U. U means it's a mass of atoms are they are representing, not mass of moles. It is just one, unified mass. Mass of atoms are represented by like this one. So if they have given you like this one, if it is 52 U, you don't have to go with the equations of number of atoms N into Na into atomicity. So we have to use this equation. If they have given the value in U, you have to use this equation. Number of atoms is equal to mass of sample by atomic mass. So mass of sample is what is 52 U. So you are substituting that. What is atomic mass? Atomic mass of helium is going to be 4 U. It's not in gram. It is not in gram per mole. Just remember, if it is in U, everything should be taken in U. 52 by 4, that is 13, will be the number of atom. So if they have given in U, just substitute, so you'll be getting the number of atom. If they have given in grams, then you have to find out the atomicity like this, N into atomicity. Just remember this difference. Okay, now look at that. This is given in 52 grams. So if they have given in the 52 grams, we cannot go directly like what we have done here. Mass of the sample by atomic mass. If they have given in grams, the number of atom is N into atomicity. This is how we have to go. Okay, so what is N? 52 gram by mass of helium is 4 into Na into atomicity of helium 1. 52 for 13, but the difference from that question, there the 13 was the answer number of atom if we were taking U, but if we are taking grams, then it is going to be 13 Na. That is what the difference is, right? Yes, number of atom is 13 Na. Mole gram entity relationship, we have already discussed that. We are recollecting the core idea. If you talk about 32 gram of sulfur, you know that 32 gram is the mass of 1 mole of sulfur, right? 32 gram of sulfur means this is the mass of 1 mole atoms of sulfur. Fine, so that contains Avogadro number of atom. If I talk about 32 gram atom of sulfur, look at that, the difference. 32 gram of sulfur means, yes, it is 1 mole atoms of sulfur, that is Na atoms. If we go with 32 gram atom of sulfur, that means it is 32 moles atoms of sulfur. That is difference. 32 gram atom is 32 mole atoms of sulfur. So gram atom is nothing but the mole. So that is going to be 32 Na atoms. 18 gram of H2O. That means 1 mole of molecules. 1 mole H2O molecule contains 18 gram of H2O. But if you talk about 18 gram molecule of H2O, then it is not 1 mole. It is 18 moles molecules of H2O. That is what the difference. Okay. So 23 gram of sodium ion, that contains 1 mole sodium ion. But if you talk about 23 gram ion of sodium, that is 23 mole Na plus ion. We have discussed that previously. So if you talk about 1 gram of oxygen, we can say that mass of one sample, mass of the sample of oxygen is 1 gram. If you talk about 1 gram atom of oxygen, that means 1 mole of oxygen is there. 1 mole atom of oxygen. 1 mole of atom of oxygen will have a mass 16 gram. You got the point? If 1 gram of oxygen is just 1 gram. If 1 gram atom of oxygen, it is 1 mole of oxygen atom, that is going to have 16 gram mass. Okay. So this is going to be the last question. Calculate the number of molecules and atoms in the following samples. Number of molecules. Look at that. 5400 U of glucose. So if it is like this, if they have given you the U, then you directly divide. I told you number of molecules, mass by molecular mass. So what is the mass? 5400 U. What is the molecular mass? 180 U. So it's gonna be 30. So 30 will be the number of molecules of glucose in 5400 U of glucose. Now you got the number of molecules. Number of atoms in, not only the number of molecules, we have to find out the number of atoms. Number of molecules of glucose is this much, 30 molecule of glucose is there. We know the formula of the glucose, it is written here. Glucose contains 6 carbon atom, 12 hydrogen atom and 6 oxygen atom. That is for the one molecule. One molecule, see, number of atoms in one glucose molecule is 6 carbon, 12 hydrogen and 6 oxygen, but we got 30 molecules. So what will be the number of atoms in 30 molecules? Carbon atom 30 into 6, 180, hydrogen 30 into 12, 360, oxygen 30 into 6, 180. This is how you have to solve if they have given 5400 U. And the other case, if they have given 5400 gram, then what is the equation for number of atoms? You know, number of atoms is N into Na into atomicity, right? So N into Na, that is nothing but the molecules. So number of molecules, if you wanted to find out, is what you have to do, number of molecules is equal to N into Na. So N into Na means N is 5400 gram by 180 gram. So it's gonna be 180 into 3 is 540 and into Na will come. So we can say that the answer is gonna be 30 Na. This is what the number of molecules. 30 Na, right? Because the number of molecules are 30 Na. Now we have to find out the number of atoms. So number of atoms in one glucose, we know that it is like this. So now it is, we have to find out for 30 Na. So 30 Na is, what we have to do, we know number of atoms is equal to, again I'm writing it multiple times so that it will be getting into your mind directly. Number of atoms and into atomicity, number of atoms, right? 6 carbon atom. So if you wanted to separately find out for the number of carbon atoms in glucose, this is going to be 30 Na into 6, 180 Na. For hydrogen, it is 30 Na into 12, 360 Na. Oxygen, 30 Na into 6, 180 Na. I hope you got clarity with the questions, that if they have given in you atomic mass unit, what you have to do to find out the number of atoms and number of molecule. If they have given in grams, how you have to find out, that also you got clarity right now, right? So just remember three equations to find out the number of moles: given mass by molecular mass, or we can find out by volume by 22.4 liters if it is at STP or NTP, that's fine. Or we can use number of particle by Avogadro number of particle. These are the three equations that you can find out the number of moles. Fine. Okay, if you have found out the number of moles, you are to find out the number of molecules, right? What was the equation to find out the number of molecules? It is N into Na. What is the equation to find out the number of atoms? You tell me, what is the equation to find out the number of atoms? N into atomicity. I hope you all got clarity with this one. So next session we'll be talking about the empirical formula, molecular formula, percentage, composition, and all kind of stuff.